In the next few minutes, we'll build a simple project from scratch, place equipment, route piping, add components, and generate professional engineering deliverables. By the end of this video, you'll have a 3D model, an isometric drawing, orthographic views, and a BOM table. Let's get started. In our framework, we'll add a simple piece of equipment, a vertical vessel, one of the most commonly used items in industrial projects. We've added the skirt support, but the vessel doesn't look quite right yet. Let's adjust the dimensions and improve its proportions. Don't be afraid of mistakes. Sometimes I reroute a pipeline 3 times before finding the best solution. Next, we'll add a centrifugal pump, the most commonly used pump type in industrial applications. Place the pump beside the vessel, keeping a realistic distance for piping and maintenance access. Here I'm using the move command and entering an exact distance. It's one of the most frequently used commands in Plant 3D and helps position components quickly and accurately. Now let's adjust the pump nozzles to match the standards used in your project, whether that's EN, ISO, ANSI, or any other local standard. Now let's adjust the vessel nozzles. We'll remove the side nozzle and create a new one on the top of the vessel. I often create a simple tank model based on preliminary dimensions. Later, mechanical engineers develop the detailed design using those drawings and requirements. Now for the fun part, pipe routing. Set the correct pressure class to match the nozzle rating, then connect the equipment with piping. Here's our first small mistake. The bottom pipe is too low, so let's raise the vessel by 1 meter and create more space for the piping. Useful tip: hold Shift plus mouse wheel to orbit around your 3D model. Here I'm switching between different visual styles and wireframe views to make hidden nozzles easier to see and select. Let's route the pipes again and see how the auto route function performs. Sometimes it creates a clean and efficient route, while other times the results can be a bit strange and require manual adjustments. This time, auto route created a strange path. Let's fix it manually and create a cleaner routing solution. In other situations, I keep it simple. I measure the required distance and move the pipe accordingly. Not every task needs a complex solution. Sometimes a quick measurement and adjustment is the fastest way to get the job done. Let's explore the tool pallets. We'll start with the most commonly used components and see how quickly they can be added to the model. The tool pallets include pre-configured valves, supports, instruments, and many other components. They're a great choice when you need a quick visualization without spending time on detailed modeling and finishing. In real projects, I use different tools for different purposes. For example, I use supports from this pallet all the time because it's fast and convenient. For valves, however, I usually generate or select models with the exact dimensions I need to match the project requirements. If you need something more specific, use the Add Custom Part tool. Here you can import your own geometry and convert it into a Plant 3D component, or choose from additional part types and define their dimensions and properties. In this tutorial, we only worked with flange valve connections. They're widely used in industrial piping and a great starting point for beginners. In future videos, we'll explore other connection types and when to use them. So we've created the snake-like pipe route. Let's move on. Here's another very useful tool you'll use frequently: visibility. You can select any object and either hide it or isolate it, making it much easier to work inside complex models. The View tab is also used very frequently. When working with smaller models, I usually use the realistic visual style. For larger models, I often switch to grayscale or 3D wireframe to improve performance and make navigation easier. Now let's select the entire line and assign a line number. This isn't just for organization or appearance. Proper line numbering is essential for generating isometrics. Pay close attention to your selection and make sure all components are included. Our 3D model is now complete. Let's generate orthographic drawings, the final result of much of our engineering work. The program will open the Ortho cube. Everything inside the cube will be projected into the 2D drawing. Simply adjust the cube to include the objects you want to show, then select the viewing direction. Choose the reference plane and set the drawing scale. Generating the second view is even easier since most of the settings are already defined from the first view. One of the biggest advantages of orthographic drawings is that they remain linked to the 3D model. If you make changes to the 3D model later, you can simply update the drawing, and the 2D views will reflect those changes automatically. Now let's add some dimensions, because without them it's just a picture. Dimensions turn a drawing into useful engineering documentation that can be understood and used by others. Every 2D view should include proper names, annotations, and labels. A good drawing should be understandable on its own, allowing someone to pick it up and immediately understand what they are looking at. Now let's return to the 3D model and generate an isometric drawing. This is where our line numbering becomes important. Instead of selecting individual components, we can simply select the pipeline by its line number and generate the isometric. This time our pipeline is longer, so the program generated 5 isometric sheets. It can be a little frustrating, but that's how isometrics work. Longer and more complex pipelines usually require more drawing pages. Here's a useful tip. Always check that all components appear in the isometric drawing. If a component is missing the correct line number, it won't be included in the isometric. This is one of the most common reasons for missing valves, fittings, or instruments. Here I quickly check that all components are in place. And finally, the most important part of the isometric drawing, the BOM table. The bill of materials lists all components required for that pipeline segment, including pipes, fittings, valves, and other items needed for fabrication and installation. The BOM table isn't limited to isometric drawings. You can also place it in orthographic drawings, which is often very useful when creating equipment layouts, general arrangement drawings, and construction documentation. Here you can select a component and place an annotation on it. Annotations help identify equipment, valves, instruments, and other items directly on the drawing, making it easier to understand and review. The BOM table is also linked to the 3D model. If you make changes to the model later, simply update the drawing and regenerate the BOM table. The component list will be updated automatically to match the latest design. This video covered the complete, basic workflow needed to prepare an industrial plant 3D project, from equipment creation and pipe routing to orthographic drawings, isometrics, annotations, and BOM tables. Everything shown here is enough to create a simple industrial project and produce the main engineering deliverables. If you'd like to go deeper, check out the other videos on my channel. There you'll find detailed tutorials on isometric generation, BOM customization, component descriptions, line numbering, orthographic drawings, and many other plant 3D workflows used in real engineering projects. Thanks for watching, and see you in the next tutorial.